So there's been a lot of interest in the OpenDroneMap project, and I wanted to share basically a how-to of running OpenDroneMap on Amazon AWS and use that to process a sample data set. Now this is a data set that I contributed a while back called Caliterra. So we're going to process these images, run them through OpenDroneMap, and ultimately have a nice orthomosaic at the end of this process. If you're not familiar with Amazon AWS, I highly recommend you check them out. Definitely a lot of cool services. Now, this tutorial is specific to Amazon AWS. We're going to be running an EC2 instance, but if you have access to a Linux VM, you can definitely follow along. So this is their homepage. I've gone ahead and logged into my account, and where you want to go is to EC2. We're going to create a virtual server, and we'll click Launch Instance. And in here, the flavor of Linux that I normally use is Ubuntu, so I'm going to select that. And what I normally do is I'll use either M3.extra large or 2x large. So in this case, let's just do an extra large. And to get a feel for what that costs, that's going to cost us about 28 cents per hour. So we have our extra large instance with 16 gigabytes of RAM. I'll go ahead and click Review and Launch. You can see some of the information there. I'll click Launch. Now you'll see this setting about choosing a key pair. You can basically create a new one, or if you have an existing one, we'll do that. I have one called Unmanned Airlines that I normally use. So I'll go ahead and select that. And now our EC2 instance is launching. I'll go ahead and click the instance ID. You can see that our instance state shows that it's running, and we have a public IP. So what I'm going to do is I'm going to copy this public IP, and we're going to use our terminal. Now if you're on Windows, you'll use a program for SSH such as PuTTY. That's a good one, or some third-party client that will allow you to connect to your EC2 instance. So I'm going to do an SSH, and I'm going to use the key pair that we defined earlier. Mine is called Unmanned Airlines, but yours may be different. And then I'm going to use the username Ubuntu at the IP address, and I'll type in yes, and you can see that now we are connected. Before we can actually do anything, we need to install the Git command line tools. That will allow us to clone the OpenDroneMap repo as well as get some of the OpenDroneMap sample imagery. So I'm going to use a sudo, and I'm going to use apt-get install the Git command line tools. We'll select yes, and then we'll allow those to install. I want to share a quick tip if you're doing this on an EC2 instance. I'm going to look at our disk space. With the root volume, you can see there's only 6.6 gigabytes available, and then you can see over here in the mount/mnt volume we have 35 gigs available. So I'm just going to change directories over there, and that's where we're going to run our imagery. And I'll just go ahead and sudo su, which will change me to a root user. That way I won't be asked for permissions and so forth. And the next step I'm going to take is I'm going to clone the OpenDroneMap repo. So I've just copied that from the URL. I'm going to type .git, and that will pull basically all of the source files from the repo to my EC2 instance. Okay, so that clone is done, and you'll look in here, you'll see an OpenDroneMap folder. So I'll just cd into that. And if you look at the files, these are the same files that you'll notice from here in the repo. So what I'll do next is you'll see in here there's this install shell script. So I'll go ahead and type /install, and that will basically go through the steps to install all the dependencies for OpenDroneMap. Our script is now done installing. You can see that it started about 2:30 UTC and finished at about 2:45. So 15 minutes for the install. Make sure that you see script finished at the end. I've seen a lot of cases with guys on the email list that have tried to run OpenDroneMap but didn't get the script to fully install. What we'll do next is we'll go to some of the sample data. I mentioned this Caliterra data before. We'll go ahead and clone this, and what I'll do is I'll go out and I'll clone it just at the directory level as OpenDroneMap, and you can see that the images are being downloaded. Our images have finished downloading. You'll see the ODM data Caliterra. So let's go ahead and go in that folder. Just make sure our images are there. You can see them. Now we're actually going to use the run script provided by OpenDroneMap and use it to process the imagery. So I'll just go to OpenDroneMap and run.pl, hit enter, and now you can see that the process is beginning. Detected the focal length and information from the image headers, and now you can see that it's resizing each of the images. Our imagery is done processing. You can see here that it started around 2:51 UTC, went through and looked at the EXIF tags to get sensor dimensions, resized the images, and then went through a process of key point matching, and you can see all the matches that it found between the various images. Then you can see it's undistorting, basically running a bunch of different algorithms. At 5:20 it finished, so about 2.5 hours later to process the imagery. Now something I want to point out, with the latest version of OpenDroneMap, you'll see that it's looking for a file called GCP list. Now by default it tries to find ground control points in a separate file, and if you don't specify that or the file doesn't exist, you'll get this error which causes a bit of a problem. So what I want to show you is how you can get around this. I'm working on the data set for the GCPs for Caliterra, but until then, what you can do, you can basically specify some runtime parameters. So instead of me having to process this imagery all over again, you can run the start with, and that'll be the ODM georeferencing step, and we're going to tell it we don't want to use ground control points, so we say false, and that will use the EXIF tags from our images. So let's go ahead and run that. You can see that it skipped a bunch of the steps that we saw earlier. About 30 seconds later, it's done. So if we look in our results folder, we'll be able to see what is basically the output, and it's located in this ODM orthophoto.png file. I'm going to copy that to my local MacBook, and then we'll take a look at it. And just as a reference, you can see I ran this SCP command to copy that orthophoto from the EC2 instance using the secure copy command over to the desktop on my MacBook. And now here is the orthophoto that was just generated with OpenDroneMap. Looks really good. You can see some seams here, but something you can always edit. Over time, we know that this software is only going to improve. So pretty excited about this. And one thing I wanted to share, as I mentioned earlier, in the OpenDroneMap wiki, there are all sorts of runtime parameters that you can use. So definitely check these out. I'll put a link to the OpenDroneMap project in the description below. So from start to finish with this EC2 instance, we spent about 3 hours bringing it up, installing OpenDroneMap, processing our imagery, about 80 to 90 images. So if we look at that, that's 28 cents per hour. So roughly 90 cents to go through that process on EC2. Not too bad. I'm willing to pay that versus some of the much more expensive options out there. Now we'll go ahead and terminate our instance. So we'll no longer incur any charges. And I hope you guys found this useful. I wanted to share the process from start to finish of installing OpenDroneMap and processing your imagery. In an upcoming video, I plan on talking more about ground control points and georeferencing your images, which is a feature that is provided by OpenDroneMap. And also, I highly recommend, if you go to the OpenDroneMap project page, you'll see that there is a user and developer
mailing lists, so definitely subscribe to those. It's some good information going on over there. If you have any questions or comments, please post them below, and until next time, thanks for watching.